In this application, we use the Acuity white light confocal probe to make a measurement on this very flat metal surface. And so what we did is we actually created a 45 millimeter by roughly 45 millimeter scan. And we have an XY stage, and every 15 microns we took a data point in X, and then we would move it down 15 microns and take another profile across it. And so here you can see this is what the data looks like after our scanning. And so we actually took a lot of high density data. So it did take a while to make this measurement. And here you can see we took 45 by 45. This scan, like I said, we did it to take a lot of high density data, and it was about a 6-hour scan. So let's come over here, and what we're going to do is I'm going to hit a leveling feature. So what this does, it will automatically level out this target. And here you can see that. And so typically with the CL2 probe, we have a measurement span of about 400 microns. And we'll have a resolution of 22 nanometers, and will be accurate to plus or minus 80 nanometers. And so it's a very accurate scan, very accurate measurement. And as we come in here, and if I use one of my profile extraction tools, we can come across here and look at this, the flatness or the coplanarity of this data. And let's take a look at that. So here you can see it does have a little bowl shape to it, and if we come in, we can zoom this up a little bit, and let's take that. And as you can see, as I move it back and forth, you can see how that changes. So let's go ahead and just look at let's just take a look at this. With the click of a button, I can generate an ISO 4287, and that says right here I've got an RSurvey on this profile of about 1.24 microns. And of course, if we zoom that up, let's just move this a little. And as we zoom that up, here you can see this is roughly a 7 millimeter part of that scan. And if we look at that also for that ISA, you can see over the 7 millimeter scan, which is pretty typically, most styluses do about a 5 millimeter profile, but you can see we're at about a 0.572 micron scan. So what this illustrates is that the white light confocal can easily make this measurement. And to give you a little bit more perspective, let's look at this in 3D. And so here you can see that scan, and as you can see, we are getting very clear edges, clear measurement around it. We can see the machining grooves, it appears, on the surface as we take a look at it with the white light. So typically anything with these sort of machining features on it, laser lines can be very difficult. They don't perform very well under 2 or 3 microns. So I would be hesitant to use a laser line if you need real high accuracy measurements. The laser can tend to generate speckle noise over these sort of surfaces, whereas with the white light probe, if we take that single spot and we profile it across the part, then we'll get a really good indication of what that surface looks like. And just to kind of give you an idea of some of these features, I mean, we are really, with this technology, we can really get down into the surface features of that. So once again, let's go ahead and take a look at a profile from north and south and see what that looks like going across those two areas. And here you can see that we are seeing little dips and artifacts, and it gives us a real good idea of that surface coplanarity. And of course we can come in here, and so typically you would use measuring tools to come in here, and if we look at that spot and right at the edge here, You know, there's a height difference of about 12.9 microns, which is about half a thousandth of an inch. And also vice versa, if we looked at the high point here, from this high point, it's about a 15 micron difference. Same in here, we're getting about a 7 micron change in height from surface to surface. So just say a quick sort of example of how the white light confocal would be a really good probe to be able to scan the bottom of that, especially if we're not looking for 360-degree scans, but maybe 1 or 2 passes across that surface.